A short video trying to explain what's going on with my buck boost inverting converter board here. This board is based off a tps65131. It's a, again, buck boost inverting converter. Take a single cell LiPo in and give you up to about plus 15, minus 15 out. Quick run through here. Got two sets of pads for volts in, for power in and whatnot. 4.7 microfarad. All the parts on here are 1206, by the way. 4.7 microfarad right here. This here is the input shut-off transistor for the positive rail, because if you shut off the chip, juice can still go basically straight through the diode, straight through to the output. So they put a P channel right here to shut off the input. The positive inductor here. The negative inductor here. Positive feedback and the feedback snubber are along here, along with this. I think that's a 15 turn 100K pot. It's a negative snubber over here, negative feedback, along with another 15 turn pot for the adjustment. And all the filter caps for the output rail, these are all 4.7 microfarad. These are also 4.7 microfarad, 4 in a row, all for the output. The back of this board is almost one solid ground plane. The only traces are right here and right here. This trace here is for the P channel enable, for the input for the positive side. This trace here is just for the power save enable, for the mode switching. You can turn on power save mode under light loads for both the positive and the negative rails. Yeah, and that's the only two traces that are on the back side here on this board. There's the positive catch diode, the negative catch diode. You can see that all these extra little vias here. The small via is needed. That's goes here over to here. That's for the switching MOSFET. There's another one around here somewhere. Doesn't matter. Every other via along here, around here, is just for ground stitching. Top layer, bottom layer ground stitching. That's it. tps65131. That's a VSON 24, I believe. VSON 24 chip. Outputs are up here. It's a ground tap. That's your V positive output. Ground tap, and that's your V negative output. This is one big chunk of PCB here. Well, big is a relative term. One big chunk of PCB for the negative side. Same thing going down here to the inductor. Big old chunk going to the switch on the chip. Same thing over here. It goes from about here to over here. The diode. So that's one big chunk for the positive. And then the feedback is some pretty thick traces back into the chip. Well, thick is, again, a relative term. And your VN goes over here to this 100 ohm resistor. Feeds into the chip for control purposes. And their filter cap for that. Thinking maybe this 100 ohm, maybe it doesn't like that much resistance on for the control side of it. So I might try like a 47 ohm or something. Just see what happens. Let's see, what else do we need to know? Yeah, VN, it's all, I should put this thing down so it focuses better. VN is all around here. One big thick trace. You know, it stops right there. Draining your source. That's the gate over here. And that's not cut over here. That on the PCB itself, that's not cut or scratched. That's just a light reflection. Okay, I guess over the oscilloscope. Okay, I'm trying to hold this as still as I can. See what happens. All right, on each rail, we've got a couple of 5 watt 82 ohm resistors, which gives me, hang on, which at 13 volts gives me 158 milliamps. Plus 13 volts, 158 milliamps. Minus 13 volts, 158 milliamps. Scope probes are all plugged in here. I got a LiPo battery holder here, which is being fed directly from the DP832, which I blew up and fixed already. one of those tp65131 LiPo charging boards off eBay. Dirt cheap, and they work like a champ. That's direct wired. You can see the wires are just about as short as I can make them. Or can you see? Yeah, the wires are just about as short as I can make them feeding into there. And the power is going through that board into the into my board. And I've got it tapped off here so I can read it on my meter, see how much loss I'm getting in the power cables going to it. And again, the load resistors are soldered directly to the circuit board, hoping I can get rid of some of the noise. Thermally, these resistors get up to about 100 degrees C. It's 212 for us Yanks. And the inductors get up to around 40-50 C, and the main chip gets up to around 60 C. So it gets pretty warm, but not stupid hot. Okay, for the equipment, let's see what I got here. Okay, I gotta hold this and do this at the same time. BK2709B, this is reading the voltage at the board after the LiPo pack, or after the LiPo or 18650 cell holder, after the TP4056. This is the voltage on the circuit board itself. This is a Fluke 8012A reading the positive output. This is a Fluke 8010 reading the negative output. Leads are reversed, so it shows negative. On this scope, I'm reading the voltage at the board as well, looking for noise on the power lines basically. And on this scope, the channel 1 is positive output, channel 2 is the negative output. I'm going to be running this at 4 volts. That'll be the high end, and just for testing for now. And what I've got to set up to is about 13 volts plus, 13 volts minus with the 4 volt input. We'll see what happens here. So, hopefully I don't lose any of this. You got 4 volts here, 1.86 amps, 7.44 watts. I got plus 13 volts on the output, minus 14.66. It shows up here as well. I'll shut this off. Scope goes down, scope comes up. And this here is my power AC coupled right now. And you can see if I hit the cursors peak to peak, it says I got 1.54 volts of wobble in there. If I check the frequency of that noise, let's see if I can get it to stabilize out here. I don't think I can. Had it. Now, nope, doesn't look like I can. Turn this up a bit. There we go. Let me turn this light off up here. There, I don't know if that does any good, but eh. Oh yeah, there we go. I can see the wave now. It's like there's a peak and runs right into that peak. That's about 30 some odd kilohertz, give or take. So, here's the deal. Channel 1 is my positive output. I'll turn that over to AC coupling. Back on, center it, and turn up the noise. Look at that noise. Yeah, of course it ain't gonna trigger on it. I'm beginning to hate this SDS7102. I'm turning the trigger up. That's because my source is the wrong one, dummy. There we go. Yeah, I'm turning the trigger down and it's going up. And my signal is not inverted. Let's try some AC coupling on the trigger. Yeah. Let's give it a little more hold off. Let's reset the hold off. Nope. Oh well. Okay, there's a stop. Let's get some more data in here. Okay. Time cursors. Yeah, time to buy a new oscilloscope. Yeah, it looks like about the same. It says down here 28 kilohertz, roughly the same as the other measurement. If I crank this up to 29.6 to match the other one, 29.6. Come on. Yeah, it's roughly match, give or take. And all this spiky noise, what frequency is that at? Let's try this. All that spiky noise, 1.3 megahertz. That's the switching frequency of the boost converter itself. Alright, let's go back here, AC coupling, let's put it back to run. See if we can get a plus minus on this. It says our peak-to-peak noise here is 130, 140 millivolts, give or take. And I think I got the bandwidth limit turned to, yeah, 20 megahertz. Yep. Okay. So, 140, 150, yeah, give or take millivolts of noise. I'm going to turn this one off and go back to the negative rail. Flip that over to AC coupling and crank it up. That's a little more defined of a wave going on here. Trigger over to channel 2. Yeah, it's a little better, but it ain't great. Let's get a few more waves in here. We can do a stop and look at it. Channel 2. Frequency is about unmeasurable because of the damn scope. Okay, it's the same 28, 29 some odd kilohertz. Yeah, that's about right. So it matches the noise and the power input here. And my voltages are still 13 plus and minus 14 and a half. And the peak to peak on the negative side, almost a half a volt peak to peak noise at that 29 kilohertz. And if you look at the spikes in the middle there, I'm going to have to resample that at a higher. Let's try that. And if we look at the spikes, there should be something there at about 1.3 megahertz, but doesn't look like there is. Looks like it's a lot higher frequency noise. Or maybe not. We're just dreaming stuff here. And from that spike to that spike, yeah, 1.3-ish megahertz, give or take. So, and that's all at a 4 volt input. I'm going to turn channel 2 back on. Yeah, they're AC coupled right over the top of each other. I don't want that. Volts per division back down to 5 volts per division. There we go. Yeah, I don't even know if you can see that in the Rigo over here. Yeah, 4 volts, 1.84 amps, 7.36 watts. Still got good volts going in, or good volts coming out. I'm going to go ahead and decrease my input voltage. Let's just drop it a tenth. Here's 3.9. And the thing here says I got 400 millivolts peak-to-peak noise up here. I got 600 millivolts peak-to-peak noise on the negative rail. Let's get on 3.5. Yeah, 400 and 600. Yeah, okay. drop it down to 3 volts, and something's going to drop out. I don't remember which. I think the negative rail drops it. Yeah. Okay, now I dropped the input voltage down to 3 volts. I got 2.955 over here. Thing still says I got 400 and 600 millivolts of noise on there. This is steadied out quite a bit, so I can see that nicely. Yeah, it's dropped down to 20 kilohertz. Hey. Positive outputs dropped to 12.5. Negative outputs dropped. Come up to negative 9.72. And I'm still getting the same average current, about 1.76. Oh, that's why. Yeah, because you drop voltage, your amp should go up, and at a certain point when it starts losing it, amperage is going to come down. Yeah. Okay, dropping the juice here, 3.0 in, 2.55. You know, just for the heck of it, I'm going to go ahead and throw up a thermal picture if I can hold this and do that at the same time. With my non-upgraded 4E4. Let's try that. See, the resistors are 100 some odd. Take. And the chip itself looks to be running about, almost 100 now. Good. That's what I wanted. I wanted to load the thing up a little bit. Beat it to failure. So, wondering how to get rid of that 600 millivolts of noise on the negative rail, and why it falls off so quick. And the datasheet says it shouldn't fall off until I get down to about 3.3 volts. There's 3.3 volts, and I'm down to 11.43 negative 11.43 volts. Whoops, 3.3 on the input. Not on, there we go, 3.3 on the input. I'm down to 11.72 on the negative rail. So it's lost regulation already. Datasheet says it shouldn't. I mean, my circuit board probably ain't perfect, but what to do? Those output capacitors are all 4.7 microfarad. Do I stack a 0.1 on top of one of them? Do I replace one of those 4 with a 0.1? Do I try to find me some sort of surface mount inductor and put it in series with the output? I don't know. I have to do a bunch of reading. That's it. And that is all.